Hi, today we're going to be learning about using the laws of exponents to simplify algebraic expressions. First, I want to quickly remind you about the laws of exponents that we've already learned. The first one is that when you're multiplying powers with the same base, you need to add their exponents and the base stays the same. Then if you're dividing powers with the same base, you subtract their exponents and you keep the base the same. If you are raising a power to a power, the base stays the same and you multiply the exponent inside and outside the brackets. If you are raising a product to a power, then you raise each of the factors to the power separately, keeping each of their respective bases the same. If you are finding the root of a power, then you need to divide the exponent by the root index. And again, the base stays the same. Anything to the power of 0 is equal to 1. And if you've got a negative exponent and the power is in the numerator, then in order to make the exponent positive, you move the power to the denominator and you can change the sign of the exponent. If your power with a negative exponent is in the denominator, then you move it to the numerator and the exponent will become positive. Okay, so now let's go and have a look at a few examples where we're actually going to be using these laws while we're simplifying algebraic expressions. Here's our first example. We need to simplify this as far as possible. In this example, we've got 3a to the power of negative 3, b to the power of 4 in brackets squared. That is being divided by, in brackets, 2ab squared, and that's cubed. And then that's multiplied by the square root of abc to the power of 0 in brackets to the power of 4. Okay, so let's have a look at how we would do this question. The first thing you need to know when you're doing a question like this is that when you've got things that are being multiplied and divided like this, you can combine it all into one thing with one fraction if you've got division. So anything that is being divided is going to go at the bottom of your fraction. So over here, I've got 3a to the power of negative 3, b to the power of 4, and that's in brackets squared. That is not being divided. There's no division in sign in front of that. So that's going to be at the top of my fraction. So I'm going to have that like this over here. And then this over here, because it is after a divide sign, it is going to go at the bottom of my fraction. Then this is a multiplication sign again, so then this is going to be at the top of my fraction with the first set of brackets. So I'm going to have over here times my square root a, b, c to the power of 0 in brackets to the power of 4. Okay, so those are at the top because I'm not dividing by them. Anything that I'm dividing by needs to go to the bottom of my fraction. So at the bottom of my fraction, I'm going to have the other set of brackets. Over here, I've got 2ab squared cubed. Okay, so I've written it as a fraction because it's going to be easier for me to work with it as a fraction. Now I'm going to go and I'm going to simplify using the laws of exponents, using what we already know about how to simplify powers. So over here, I've got a set of brackets with an exponent outside. I need to raise each of the factors inside the brackets to that power outside. So 3 to the power of 2, I can write it as 3 to the power of 2, or I can work it out straight away. That is equal to 9. Okay, when you have a number inside the brackets, you raise it to the power, so it would be 3 squared, and then I can work it out, and that's equal to 9. I can't do the same thing with variables because I can't actually work out what they're equal to. So what I'm going to do here is a to the power of negative 3 squared is a to the power of negative 3 times 2 is negative 6. Okay, remember when we are raising a power to a power, we multiply the exponents. But please take note over here, I did not multiply the 3 by 2 because the 3 is not an exponent. The 3's exponent is actually 1. So I multiplied the 1 by 2 and I got 3 to the power of 2, which is equal to 9. So that's where the 9 came from. Okay. Then over here, I've got b to the power of 4, and I need to square that, becomes b to the power of 8. Okay, so that's my first set of brackets. Now I've got rid of the brackets. Now I'm going to go on to this root sign over here. So I've got times, then the square root of, and over here I've got a, b, c to the power of 0 in brackets, and that's to the power of 4. Now I have a choice. I can either get rid of the brackets inside here first, by multiplying each of these exponents by the 4 and then find the square root of that. Or I can find the square root of this whole power, which has the base abc to the power of 0. Okay, so that over here is the base of the 4. So I can take the square root of that because this is an even number. I can do it because it's the square root. So I'm going to be dividing by 2. Okay, so it's up to you which way you want to do it. It doesn't really matter either way. So what I'm going to do is I'm going to take the square root, and I'm going to divide that 4 by 2, and I'm still going to have brackets then. So it's going to be a, b, c to the power of 0, and that's to the power of 2, because now I've taken the square root. So this power's base is a, b, c to the power of 0. The exponent is 4, and I'm dividing that by the root index, which is 2. Okay, so that is over my denominator, which I'm going to get rid of these brackets here as well. So I've got 2 to the power of 1 to the power of 3 gives me 2 to the power of 3, which is 8. Okay, so again, you can write 2 to the power of 3 and then change it to 8, or you can change it to 8 straight away. Okay, but remember, you're not timesing the 2 by 3 because the 2 is not a power, or it's not an exponent. The 2's exponent is 1. Right, then I've got a. Its exponent is 1, so when I multiply that by 3, I get a to the power of 3, and then b to the power of 2 times 3 is 6. Okay, so that's what we get for our first step. Now the second step, I'm now going to go and get rid of these brackets as well over here. So I've got 9, a to the power of negative 6, b to the power of 8, and then over here I've got times. Now a to the power of 1 to the power of 2, I times the 1 by 2 and I get a to the power of 2, or it's just a squared. Then b to the power of the same thing happens, b to the power of 2, and then here I've got c to the power of 0 times 2 is 0. Now I could have already sorted this out right at the beginning. If you wanted to, you can change that c to the power of 0 right at the beginning to a 1, because anything to the power of 0 is 1. I'll do that in the next step though. Okay, so over here I now have my denominator, which isn't changing at the moment, so 8a cubed b to the power of 6. Okay, so in my next step, I'm now going to change the c to the power of 0 to a 1. And at the same time, I'm going to move my negative exponents, my powers with my negative exponents. So this a to the power of negative 6 has a negative exponent. There aren't any other negative exponents, so there's nothing else that I need to move. So I'm just going to move that, and at the same time, I'm going to change this to a 1. But I need to show that I'm changing it to a 1. I mustn't just leave it out, because otherwise it looks like I forgot to write it. Okay, so it's 9. Then the a to the power of negative 6 is going to move. So I'm not writing that right now. That's going to come at the bottom. So there's 9b to the power of 8 times a squared b squared times 1. So now I've changed that c to the power of 0 to a 1. And at the bottom, I've got 8a cubed b to the power of 6, and then I'm bringing this a to the power of negative 6 down to the bottom of the fraction, so it becomes times a to the power of positive 6. Okay, so now I don't have any negative exponents to worry about. Now I'm going to go and start cancelling out things that I can. So over here, I'm looking for things that have the same base, things that I can multiply together and add their exponents, or things that I can divide and subtract their exponents. Okay, so I'm going to look at my a's first. So over here, I've got a squared. Here I've got a cubed, and here I've got a to the power of 6. So if you look at the bottom, I've got a to the power of 3 and a to the power of 6. Because I'm multiplying those, that's going to be a to the power of 9. So I've got 9 a's that I'm multiplying at the bottom, and there are 2 at the top. So I'm going to subtract the 2 from the 9, or I can subtract the 2 from here if I want to, and that gives me a, and then I can multiply it here. It doesn't matter what order you do it, so long as you cancel out this a to the power of 2 completely, that gives you 1, and you multiply what's left over here, that gives you 8 times a to the power of 6, which is a to the power of 7. So I'm going to have a to the power of 7 in my denominator. Then we're going to look at our b's next. So the b's, I've got b to the power of 8 at the top and b to the power of 2 at the top, and at the bottom I've got b to the power of 6. So I can simplify that. B to the power of 6 goes in there once, b to the power of 6 goes in there, and I'm dividing it, so it's b to the power of 8 minus 6 is 2. Okay, and then I'm going to go and simplify what I can now. So over here in my numerator, I've got 9. I couldn't do anything with the numbers because I can't simplify 9 and 8. Okay, so the 9 and the 8 aren't changing. So I have got 9 at the top, and then I've got b squared times 1 times b squared times 1. So I'm just looking at the b's. B squared times b squared, they have the same base, so I can keep the base the same and then add their exponents. So it's 2 plus 2 is 4. And then at the bottom of my fraction, I've got my 8. And then a times a to the power of 6 is a to the power of 7. So that's what we should get for that example. Okay, so now I'm going to give you a few that you're going to do for yourself. Here's the first one you're going to do. you've got 3a to the power of 4b to the power of 3 times 4a squared b to the power of 5. I'm going to give you 30 seconds to simplify this example. Okay, so let's go through that quickly and see what you should have got. So with this example, the very first thing you're going to do is, because there are no brackets or anything, I can go straight ahead and do my multiplication. So I'm going to multiply my 3 and my 4 together, and that gives me 12. Then I'm going to multiply my a's. So I've got a to the power of 4 and a to the power of 2. That gives me a to the power of 6, because I add those exponents. And then my b to the power of 3 times b to the power of 5. The base stays the same, and I add the exponents. That gives me b to the power of 8. So that's what we should have got for question A. Right, now I'm going to give you the next one. So in this question, you've got 2x squared yz cubed multiplied by, in brackets, 3x cubed y to the power of 4z to the power of 5 all squared. And I'm going to give you 1 minute to do this question. Okay, so let's go through that and see what you should have got. So the first thing you're going to do in this question, you need to sort out these brackets over here. So this 2x squared yz cubed isn't going to change for now. Then in these brackets, I've got 3, which I need to raise to the power of 2. That gives me 3 squared, which is 9. So I've got 9. And then I've got x cubed, which I need to square. That gives me x to the power of 3 times 2 is 6. Then y to the power of 4 squared is y to the power of 4 times 2, which is 8. And then z to the power of 5 squared is z to the power of 5 times 2, which is 10. Okay, so that's what you should have got inside your brackets. Now, I'm still keeping those in brackets because I still need to multiply with what is over here. Okay, now I'm going to go and multiply these together. So I've got my 2 times 9, that gives me 18. And then I do my x's. X squared times x to the power of 6 is x to the power of 8. Then my y's, I've got y times y to the power of 8. That's y to the power of 1 plus 8 is 9. And then z to the power of 3 plus 10 is 13. So that's what we should have got for question B. Right, let's go on to question C. In question C, you've got 5a in brackets to the power of 0 plus 5a without brackets to the power of 0. I'm going to give you 30 seconds for this question. Okay, so let's go through that question quickly. So with this one over here, you have to be careful because you have to treat them differently because of these brackets over here that aren't over there. So over here, remember anything to the power of 0 is 1. So over here, my base is 5a. So this whole thing is to the power of 0. So the whole thing is going to change to 1. Plus, now over here, only the a is to the power of 0, which means that only the a is going to change to 1. The 5 is not going to change to 1. So it's going to be 5, and remember this is multiplied together. So it's 5 times a to the power of 0, which is 1. So only the thing that has the power of 0 changes to 1. So over here, the whole thing is to the power of 0, so the whole thing changes to 1. But in this one over here, in this term, only the a is to the power of 0, so the 5 stays the same, and it is multiplied by 1. Okay, so now I'm going to go and work that out. So 1 plus 5 times 1 is 5, and that gives me 6. So for that question, you should have got 6. Okay, next one. For question D, you've got a fraction where the numerator is 2x cubed y squared z to the power of 5 over the denominator, which is 6x to the power of 4 y cubed z cubed. I'm going to give you 1 minute to work this one out. Okay, so let's go through that question. Right, so over here, the first thing we're going to do is we need to simplify our numbers. Okay, there's nothing else I need to do. There are no brackets or anything that I have to worry about. So I can go straight ahead and start cancelling things out. So for the numbers, we simplify it in the same way that you would with any other common fractions. We say 2 goes in there once, 2 goes in there 3 times. Okay, so my numbers simplify to 1 over 3. Now let's see what else we have. So the x cubed and the x to the power of 4, they have the same base. So I can simplify those. So over here, I simplify those by dividing, so that means that I'm going to subtract the exponents. And I always am going to end up with the answer where the higher exponent is. So this one is going to become 1, and this is going to be x to the power of 4 minus 3, which is 1, which I don't need to write. Okay. Then over here, my y's, the same thing is going to happen. I have y cancelling, or y squared cancelling out. And over here, the y to the power of 3 is going to be y to the power of 3 minus 2, which is 1, which I don't need to write. And then my z's, I've got z to the power of 5 and z to the power of 3. The z to the power of 3 is smaller, or has a smaller exponent, so that's going to cancel out. And over here, I'm going to have z to the power of 5 minus 3, which is 2. So at the top of my fraction, I've got 1 times 1 times 1 times z squared. So that's z squared at the top, over... At the bottom of my fraction, I've got 3 times x times y times 1. So that's 3xy. So that's what we should have got for question D. Z squared over 3xy. Right, let's go on to question E. In question E, you've got in brackets 3a cubed b to the power of negative 2 all squared. And that is over 4a to the power of 6 b to the power of negative 3. Right, I'm going to give you 1 minute for this question as well. Okay, so let's go through that question and see what you should have got. So in this question, the first thing we need to do is sort out these brackets that are being squared. So I'm going to square that and remove the bracket. So over here, I'm going to have 3 to the power of 2 is 3 squared, which is 9. Then a to the power of 3 squared is going to be a to the power of 3 times 2, which is 6. And then b to the power of negative 2 squared is negative 2 times 2, that's negative 4. Okay, so that's what I have at the top of my fraction when I get rid of those brackets. And at the bottom of my fraction, I'm not changing anything yet, because all I was doing in this step was just getting rid of this bracket. So I've got 4a to the power of 6, b to the power of negative 3. Now remember, you cannot move something that has a negative exponent while it is in brackets, because otherwise you're not going to end up doing what the brackets are there for. So you need to be careful not to try and move that first before getting rid of those brackets. You have to get rid of the brackets first. Okay. Now we're going to go and move our negative exponents, our powers with negative exponents. So over here I've got b to the power of negative 4, here I've got b to the power of negative 3. They are actually just going to switch places because they both have negative exponents. So I've got 9, a to the power of 6, and then the b to the power of negative 3 is going to come to the top and become b to the power of 3. Then at the bottom I've got 4, a to the power of 6, and the b to the power of negative 4 is going to go to the bottom and become b to the power of 4. Okay, so now I can go and simplify that. So my 9 and my 4, I can't simplify because they don't have a common factor that I can divide by, so they're going to stay as they are. The a to the power of 6 and the a to the power of 6 are exactly the same, so I can just cancel those out completely. They become 1 and 1. The b cubed and the b to the power of 4 are going to cancel out. The b cubed is the smaller one, so it's going to become 1, and the b to the power of 4 is going to become b to the power of 4 minus 3, which is 1, which I don't need to write. So that's going to be b at the bottom there. So now at the top of my fraction, I've got 9 times 1 times 1, which is 9, over, at the bottom of my fraction, I've got 4 times 1 times b, so that's 4b. So that's what you should have got for question E, 9 over 4b. Right, let's go on to question F. In question F, you've got in brackets a squared b to the power of negative 3, and that is all cubed. Then you're dividing that by a to the power of 4, b to the power of negative 4, and then multiplying by, in brackets, ab squared, all squared. Okay, so I'm going to give you 2 minutes to do this question. Okay, so let's have a look at how to do this question. So this is very similar to the question that I did with you earlier, where we had things that we multiplied and divided. So when you have something like this, where you've got something divided by something else, I always recommend writing that as a fraction. Okay, so over here, I'm going to convert this and write it as a fraction. So what is going to be at the top of my fraction is everything that is not being divided by. So over here, I've got this is not being divided by. It's going to go at the top of my fraction. A squared b to the power of negative 3 in brackets cubed. And then this bracket over here is also not being divided by, so it's going to be times a b squared in brackets squared. Okay, and then at the bottom of my fraction, I have anything that I'm dividing by. So that's going to be this one over here. I've got a to the power of 4, b to the power of negative 4. Okay, so once you've done that, then you can go and start simplifying like you would normally. So the first thing I need to do now that I've got it as a fraction is get rid of those brackets. I don't like those brackets. So I want to get rid of the brackets, and then I can go and carry on simplifying. So over here, to get rid of these brackets, I'm going to raise everything to the power of 3. So a to the power of 2 to the power of 3 is a to the power of 2 times 3 is 6. And then b to the power of negative 3 cubed is b to the power of negative 3 times 3, which is negative 9. And that's being multiplied by, over here I've got a to the power of 1 squared is a to the power of 1 times 2, which is a squared. And then b to the power of 2 times 2, which is 4. Okay, at the bottom of my fraction, I don't need to do anything at the moment because I didn't have any brackets to get rid of. So that is just going to stay as it is. Right, so now that I've got that, I need to go and sort out my powers with negative exponents. So now I've got this one over here that I need to move, and that one that I need to move. So everything else is going to stay where it is. So I've got a to the power of 6, then I've got times a squared, b to the power of 4, and then I'm going to be bringing this up over here. The b to the power of negative 4 is going to come up and join these at the top and become b to the power of positive 4. That is over a to the power of 4 is staying where it is. And then this moved, so I'm not going to write that anymore. But here, the b to the power of negative 9 is moving to the bottom. It's going to join the a to the power of 4, become b to the power of 9. Okay, so now I can go and simplify by cancelling out and multiplying. So over here, the a to the power of 4, I can cancel with the a to the power of 6. And that cancels completely over here and leaves me with a to the power of 6 minus 4, which is 2. So that's a to the power of 2 at the top. I can't cancel any other a's out because there are no other a's at the bottom here. So I'm going to be multiplying those together. Then for my b's, I've got b to the power of 4 times b to the power of 4 at the top and b to the power of 9 at the bottom. So if I cancel these out, that gives me 1. And b to the power of 9 minus 4 is b to the power of 5. Then over here, b to the power of 4 and b to the power of 5 cancel, give me 1, and b to the power of 5 minus 4, which is 1. So that's just b. So at the top of my fraction, I'm left with a squared times 1 times 1. That's a to the power of 4 over, at the bottom of my fraction, I have 1 times b, which is just b. So for that question, you should have got a to the power of 4 over b. Right, let's go on to the next one. Question G. You've got the cube root of x to the power of 6y cubed times the square root of xy squared in brackets squared. Okay, so I'm going to give you 1 minute for this question. Okay, so let's go through that and see what you should have got. Right, so the first thing we're going to do over here is sort out this cube root. So I've got the cube root of x to the power of 6. When I'm taking a root of a power, I'm going to divide the exponent by the root index. So I'm going to divide the 6 by 3, and that gives me x to the power of 2. And then I do the same thing with the y cubed. That's going to be y to the power of 3 divided by 3, which is 1, but I don't need to write the 1. So it's x squared y times. Now over here, I had one similar to this earlier as well, where you had a square root of a bracket squared. Now, like in the last one, I have a choice. I can either take the square root of the whole thing and divide that exponent by 2, or I can first get rid of the brackets inside and then take the square root of what's I'm left with. So you can choose which way you want to do it, so long as you end up with the same thing as me. Okay, so I'm going to choose to first sort out the square root of my whole power to the power of 2 over here, where this is the base. Okay, so that means that my square root is going to disappear. I'm going to have xy squared, and then this exponent is going to be divided by 2, leaving me with 1. And that's why I haven't put this in brackets, because if it's to the power of 1, it doesn't need to be in brackets. If you put it in brackets, it's fine, it doesn't matter, but it doesn't need to be in brackets. So I have x squared y times xy squared. So now I'm going to multiply my powers with the same base. So I've got x squared times x gives me x cubed, and then y times y squared is y cubed. So for this question, you should have got x cubed, y cubed. Okay, now we're going to go on to question H. In question H, you've got in brackets a squared plus 2a cubed, all to the power of 0, multiplied by, in brackets, 3a to the power of negative 1 squared. Okay, so I'm going to give you 1 minute for this question as well. Okay, so let's go through that and see what you should have got. Right, so in this question, we've got something interesting over here. A squared plus 2a cubed inside the brackets. Now, this is the first question we've had where we've had any pluses or minuses. Okay, now, when you get something like this, normally you would have to either work it out, you'd have to simplify what's inside the brackets first before you can raise it to the power, or you would have to do what we're going to be learning about in the next lesson, where we're going to be learning about raising a bracket to the power of 2 or whatever, and there's a special way that we have to do that. Now, I haven't taught you how to do that yet, but for this particular one, it's not a problem because the exponent outside the brackets is a 0. And remember, anything to the power of 0 is equal to 1. So if I just take this as a base to the power of 0, it's going to change to 1. So anything to the power of 0 is going to change to 1. So this whole thing is going to change to 1. Okay, because it's the power of 0. And that is being multiplied by, over here, I've got 3a to the power of negative 1 squared. So that's going to be 3 squared, which is 9, okay? And then a to the power of negative 2. So, like I said, you can choose to write it as 9 straight away, or you can choose to write it as 3 squared. In this one, I chose to write it as 3 squared, and then I'm going to write it as 9 in the next step. But if you chose to write it as 9 straight away, that's fine. Okay, now I don't need to write that 1 anymore because it doesn't do anything. So now I have 9, and then the a to the power of negative 2 I'm going to be moving. So I have 9 at the top of my fraction, and remember this is actually, even though it doesn't look like a fraction, it is actually a fraction. The denominator is 1, okay? So the a to the power of negative 2 is going to move down to the denominator and become a to the power of positive 2. So I have 9 over a to the power of 2. That's what you should have got for question H. Remember, anything to the power of 0 is going to change to 1. Doesn't matter what the base is. The only time that that's not going to happen is if the base is 0. Then you can't have 0 to the power of 0. It's not going to work. But any other base to the power of 0 will give you 1. Doesn't matter how complicated that base is. Okay, right. Now we're going to go on to our next example. In this example, we've got the square root of 9a squared b to the power of 4 plus 2b cubed over a to the power of negative 1 minus 2ab times 3b squared plus 21a squared b over 7ab to the power of negative 1. Okay, so let's go and have a look at how we do this question. Okay, so this question is quite different to the ones we've had so far because we have got pluses and minuses. So we need to make sure that we do everything in the correct order using BEDMAS. Okay, so first I'm going to identify where my terms are. So my first term is this over here. My second term is from the plus up to before that minus. The next term is with the minus up to before the plus, and the last term is that plus up to the end. Okay, so in my first term, the only thing I need to do here is I need to get rid of that square root sign by square rooting what's inside. So the square root of 9 is 3. The square root of a squared is a, and the square root of b to the power of 4 is b squared, by dividing those exponents by the root index, which is a 2. Okay, then the next term is a plus over here. Now I've got 2b cubed over a to the power of -1. The only thing that I need to do in this one is move this power with a negative exponent to the top of my fraction. So it's going to be 2, and then because I don't have to do anything else, I can straight away put it in the correct order. So the a should go in front of the b to put it in alphabetical order. So I need to have 2a to the power of 1, which is just 2a, and then b cubed. So that's what I should get for my second term over there. Now my third term, I've got a negative times a positive, so it's minus 2 times 3 is 6, and then a, and then b times b squared is b cubed. Okay, so that's what I had to do for the third term. I just had to do the multiplication. Now the fourth term, there are a couple of things I have to do here. I've got a negative exponent, and I'm also going to have to simplify the fraction as well. So I'm going to first move that power with a negative exponent. So I've got 21 a squared b times this b is to the power of -1 is going to move to the top and join it. So that's going to be b at the top of there. Over, the only things that are left at the bottom here are 7 and a. Okay, so now I'm going to go and simplify that in the next step. So I've got 3ab squared plus 2ab cubed minus 6ab cubed. And then, so none of that is changing at the moment. Now I'm going to go and simplify this. So now I'm going to go and say I've got 21 and 7. 7 goes in there once. 7 goes in there 3 times. Then the a squared and the a can cancel. This cancels completely, giving me 1, and that leaves me with a at the top there. And then the b and the b, I'm going to be multiplying those together. Okay, so over here, the denominator is just going to be 1. Now, when you have a denominator of 1, you don't need to write it. So this isn't going to be a fraction anymore. So it's just going to be plus 3a, and then b times b is b squared. Okay, so once I've got to this point now I need to go and do my addition and subtraction. The addition and subtraction, I have to be careful with though. I can only add or subtract like terms. So I have to identify which of these terms are like terms. So over here, I've got 3ab squared, and over here, I've got plus 3ab squared. And here, I've got plus 2ab cubed and minus 6ab cubed. Now, you can write these together. So 3ab squared plus 3ab squared, and then plus 2ab cubed minus 6ab cubed. But you don't need to show the step where you collect them. You can go and simplify straight away. So 3ab squared plus 3ab squared is 6ab squared. Remember, when we are adding like terms, the variables and exponents don't change. We just add and subtract the coefficients, which are the numbers in front. Okay. And then over here, I've got plus 2ab cubed minus 6ab cubed. So it's 2 minus 6 is minus 4. And the ab cubed doesn't change. ab cubed. So that's what you should get for that example. Okay, so now I'm going to give you a few like this that you're going to do for yourself. Here's the first one you're going to do. You've got 2x in brackets cubed minus 3 over x to the power of -1 plus 3x times 4x squared minus the square root of 25x squared. Okay, so I'm going to give you 1 minute for this question. Okay, so let's go through that question and see what you should have got. Okay, so the first thing I need to do is identify where my terms are. So I've got a term over here, 2x in brackets cubed. Then my next term is from this minus up to just before the plus. Then the next one is from the plus up to before the next minus over there. And then the last term is from the minus to the end. Okay, so in the first term, what I need to do is get rid of these brackets. So I've got over here 2 cubed is 8, and then x cubed. So that gives me 8x cubed. The next one, I need to change this x to the power of -1 to have a positive exponent by moving it to the top. So it's going to be minus, and then because there's nothing left to the bottom, I don't need to write it. So it's just going to be -3, and then x to the power of 1, or just x. Okay, so that should have changed to -3x. The next term, we're going to be multiplying these together. So I've got plus, and then 3 times 4 is 12. X times x squared is x cubed. And then over here, I need to work out my square root. So it's going to be minus, the square root of 25 is 5, and the square root of x squared is x. Okay, so that's what you should have got for that line of working. Now we're going to go and simplify further by collecting our like terms. So I need to identify what my like terms are. So over here, 8x cubed and plus 12x cubed, those are like terms. And I've got -3x and -5x, which are like terms. Okay, so we're going to go and add these, 8x cubed and 12x cubed. So 8 plus 12 is 20, and the x cubed doesn't change. So it's 20x cubed, and then -3x minus 5x, -3 minus 5 is -8, and then the x doesn't change. So you should have got 20x cubed minus 8x for that example. Okay, let's go on to the next one. Question B, you've got in brackets 2a times 3a squared minus a cubed, and that's all squared. Then it's plus 3a to the power of 0 minus, in brackets, 2a cubed, all squared, and then minus a to the power of 6 times a to the power of -6. I'm going to give you 2 minutes to do this question. Okay, so let's go through that question and see what you should have got. So for this one, you had to be careful with this set of brackets over here because there's quite a lot that you need to do here. You can't go ahead and start squaring yet. Okay, so first of all, I'm going to identify where my terms are. So this is my first term up to before the plus over there. Then the plus 3a to the power of 0 is my second term. Then the minus in those brackets is my third term. And then the minus up to the end is my fourth term. Okay, so in the first term, inside these brackets, I need to use BEDMAS. The first thing I need to do is the multiplication. So I've got 2a times 3a squared. That gives me 2 times 3 is 6, and a times a squared is a cubed. So I get 6a cubed minus a cubed, and that is all squared. Then over here, my second term, I can go and simplify this a to the power of 0. So that's plus 3 times anything to the power of 0 is 1. So it's 3 times 1. Please be careful, the whole thing isn't changing to 1. Only the a to the power of 0 is changing to 1 because it's not in brackets. So the 3 is not being raised to the power of 0. The 3 is just 3. Okay, so it's 3 times 1, and then minus. Here I've got 2a cubed in brackets squared. So I have 2 squared, which is 4. And then a cubed squared, which is a to the power of 6. And then over here, I'm going to write this as a fraction. So it's minus a to the power of 6 over a to the power of 6, because I'm changing that power with a negative exponent to have a positive exponent. So it's going to the bottom of my fraction. Okay, so now I'm going to go and simplify this further. So over here, the 6a cubed minus a cubed, I can't square it yet because I still have 2 terms inside my brackets over here. So I'm going to go and simplify that. They are like terms, so I can simplify them. 6a cubed minus a cubed is 5a cubed. So inside my brackets, I now have 5a cubed, and that needs to be squared still, plus 3 times 1 is 3, minus 4a to the power of 6, and then this over here, anything divided by the same thing will give me 1. So those cancel, giving me 1. But it doesn't just cancel out completely and disappear. It cancels out, giving me 1. So it's 1 over 1, which is 1. Anytime you have a fraction where the top and the bottom are the same as each other, you end up with 1. Okay, so that's minus 1. Right. Now I need to go and get rid of these brackets over here still. So 5a cubed in brackets squared, that's 5 squared, which is 25. And then a cubed squared, I times the 3 and the 2, and that gives me a to the power of 6, plus 3 minus 4a to the power of 6 minus 1. So now I need to look for my like terms. So over here, I've got 25a to the power of 6 and minus 4a to the power of 6. And then my other like terms, even though they don't look like terms in terms of having the same variables and exponents, they are both constants. So they are like terms. Okay, so they can be added and subtracted. Right, so now I've got 25a to the power of 6 minus 4a to the power of 6. So it's 25 minus 4 is 21. And the a to the power of 6 doesn't change. So it's 21a to the power of 6. And then I've got plus 3 minus 1 is plus 2. So that's what you should have got for question B. Now we're going to go on to the last question for today, which is question C. Here you've got 2x squared minus 3x to the power of negative 1 plus 4x to the power of 5 over x cubed plus 4x to the power of negative 1. Now before you start this one, I just want to let you know that over here, this 3x to the power of negative 1 and the 4x to the power of negative 1, I don't recommend changing those to fractions because you're going to need to add and subtract them. And at the moment, they already have the same variables and exponents, so they already are like terms. Once you have simplified the like terms, then you can go and sort out that negative exponent. Okay, so I'm going to give you 2 minutes to work on this question. Okay, so let's go through that question and see what you should have got. Right, so the first thing we're going to do is identify where our terms are. So over here, I've got my first term, 2x squared. My next term is negative 3x to the power of negative 1. My next term is positive 4x to the power of 5 over x cubed. And my last term is plus 4x to the power of negative 1. Okay, so in this particular question, there wasn't a whole lot of simplification for you to do before you could go on to your collecting of your like terms. I can't do anything to that term, so it stays as it is. Then I told you I don't recommend changing this to 3 over x and changing that to a positive exponent yet. We're going to do it later on after we have collected our like terms, because it's actually going to be easier to work with it while it is like this. Okay, so that's going to stay as it is for now. But this I need to go and simplify. So over here I've got x cubed and x to the power of 5, that changes to 1. This becomes x to the power of 5 minus 3, which is 2. So you should have got 4x squared over 1, which is just 4x squared. Remember, when your denominator is a 1, you don't need to write it. That's just 4x squared. And then plus, again, the same thing with this one as with that one. I'm not going to change it. I'm going to keep it as 4x to the power of negative 1. Now, the reason that I was doing that is because you can see that these are like terms. So I can go and add and subtract my like terms like I normally would. It doesn't matter that those exponents are negative. Once I have done that, then I will sort out my negative exponents. But it's going to be more tricky if I change it to a fraction and have it as 3 over x and 4 over x, because you don't quite know how to work with that yet. You're still going to learn how to do algebraic fractions, but at this point it's actually easier to work with it like this. Okay, so I'm going to have over here my like terms 2x squared and 4x squared. I need to add those. That gives me 6x squared. And then over here, I've got minus 3x to the power of negative 1 and plus 4x to the power of negative 1. Those are also like terms. So negative 3 plus 4 gives me positive 1. So it's plus 1x to the power of negative 1. Now I don't need to write the 1. So it's just plus x to the power of negative 1. Now I need to go and change that negative exponent and make it positive, because we always need to leave our final simple version of our algebraic expression with positive exponents. So I need to change that to a positive exponent now. Okay, so now this is going to be 6x squared. That's not changing, but in this term I've got plus, then this x to the power of negative 1. At the moment it is a numerator. You can't see the denominator because it's a 1. Okay, so this x to the power of negative 1 is going to move to the bottom of my fraction and become x to the power of positive 1. And the numerator is going to change to 1 because there's nothing else left. So it's going to be 1 over x to the power of positive 1, or just x. So you should have ended up with 6x squared plus 1 over x for that question. And that is how we use the laws of exponents to simplify algebraic expressions. Now that we've learned the concepts in this lesson, it's important to practice, practice, practice. If you haven't already got the worksheet that goes with this video, you can find it by clicking on the link in the description below. The worksheet comes with an extra exercise full of questions for you to work on to master the concepts covered in this lesson. If you found this video helpful, please hit the like button so that others can benefit from it too. Also, be sure to subscribe so that you can easily find my other lessons, and hit the bell so that you will get notified about lessons as I upload them.